Welcome back to the channel, and this is what we'll be talking about in this video. So, although the style of the video will seem a bit more like it's made using the ideology of a scrapbook, right, having bits and pieces being cut and put together, I hope that just like a scrapbook, um, you will see the value in this video, and I'm just happy to share my knowledge with you in whichever way, shape, or form. So at the end of the day, if you learn something, that's a win for me. So after this introduction portion, you'll be watching a video that was recorded as part of an online course that I made. So if you like it, do check out my course. I'll have the link in the description, and you can see the link too at the bottom of this video together with my YouTube and Instagram socials. Alright, so enough with the introduction and let's get started. So your sine rule can be used for all triangles. So that's why they are forming a different branch, right? Your sine rule, cosine rule, right? As well as your half AB sine C can all be used for all triangles. So it doesn't have to be right angle triangle. So it can be used for all triangles. So that's why they are forming a different branch. And over here, I have done a quick recap on the sine rule. So let's just visit it. So for sine rule, you will realize that over here I have two formulas. So the sine rule, much like your tuakaso, can be used to find length, or it can be used to find angle. So when finding length, I like to use this formula over here. Why? Because as mentioned in previous videos, I like to have the unknown being at the top left of the formula, right? So when finding angle, I'll use this formula over here. Same thing because the unknown is at the top left of the formula. And just a quick example using this triangle to show how we put in the values to use the sine rule. So imagine you have this triangle over here and you're trying to find this length. All right. So what I'll do is I'll call this length angle A. I'll call this length A, and then therefore this angle will be angle A. Right? And we went through this very important point that the angle and the length, they are opposite to each other, is the one pair. So you're free to name the length A or B or C, but the important thing to note is that the length and the angle, if you call this length A, this must be called angle A. All right. So with that, I have my length A and angle A. Now, what I'm gonna do is then I will identify another pair where I know the angle and I know the length of. All right. And previously we mentioned also this is actually the telltale sign as to whether you can do a sine rule or not. The reason being, if you don't have a pair of angle and length being opposite to each other, so one pair of angle and length, where you know both the value of the angle and the length, you cannot use sine rule. All right. So in this case, for this example, we have this 100 degrees and we have this 15. That is one pair. So I'll put it in. So very conveniently, A is my angle A, so sine 50, length B, all right, and then my sine 100 degrees because this is my angle B. And then how I'm gonna get my length A is by solving for A. So that's why what we'll do next is we'll throw your sine 50 upwards. So over here, very commonly people do cross multiplication, but what I like to do is to have the unknown being at the top left, so I can just throw the sine 50 upwards and then have this as what A is. So A equals to this 15 sine 50 over sine 100 degrees. And I can just put this into my calculator, make sure it's in degree mode, and then get my answer for A. So after we solve A, length A, I can put this in here. This is now 11.7, all right, 11.7 3SF. Okay, now I will show you how to use the sine rule to find angle. All right, so to use the sine rule to find angle, I will use back this triangle, but just imagine that I don't know this angle right now. Okay, I don't know this angle, but because this is the angle that I want to find, I'll call this angle angle A, so that if it's at the top left corner again. And because this is angle A, this will be length A. So putting that in, this is length A. I'll still use the same pair that I know both the length and the angle of. So over here, sine 100 degrees and then 15. And how I'm going to solve for sine angle A is to throw this up again. So multiplying it upwards, I'll get this, and that is what sine angle A is. And notice by keeping what you want to find at the top left corner, it makes it very easy to go ahead and solve for the unknown that you want. You don't have to play around with too much algebra, do cross multiplication, and then get lost in between, right? Trying to make something the subject of the formula and then solving for it. So that's why I like to find, I like to put the thing that I like to find at the top left. Okay, so anyway, with that, this is my sine angle A, and doing a sine inverse, this is the formula that I'll get. I mean, this is the answer that I'll get, right? And you know that it's the same as what we previously established angle A as. So angle A was previously 50 degrees and we use it to find length A. So of course, now if I use the value that I found uh, length A to be, I will get back 50 degrees here. So this is consistent.
Thank you for watching till the end of the video, and I hope that you have learned something. If you did, don't forget to give this video a like and comment on one thing that you like about the video, right? Also, please help to share this video and subscribe to the channel because that will really help me a lot, and your support means the world to me. So if you don't like the video, no worries. Comment and let me know what you didn't like about it so that I can improve and I can change in the next few videos. Alright, so that's it. Thanks all, and I'll see you in the next video.